Early in the 1976 North Sea pipelaying season, Viking Piper, built by IHC Holland, laid 3 kilometers of 36-inch diameter pipe in one day, a world record for this size of pipe. This came as no surprise to the men who designed her, for she's a semi-submersible of over 50,000 tons, built to lay pipe in greater water depths and faster than any previous barge, and most important of all, to continue to do so with pinpoint accuracy in seas that defeat conventional barges. Normal lay barges float on the surface of the sea and are highly sensitive to wave motion. If you can reduce the surface area the waves act upon, turbulent water flows through the hull, greatly reducing barge motion. Viking Piper achieved this by lifting the working deck out of the water on 6 supporting columns standing on submerged pontoons. Waves then flow through the transparent hull. This new concept in lay barge design needed to be thoroughly tested, so model barges were subjected to simulated severe storm conditions at the Netherlands Ship Model Basin. They passed with flying colours, but then the builders, IHC Holland, were faced with the daunting task of translating those ideas into a huge structure made up of components weighing as much as 1,600 tons each. The assembly of these very large components posed a problem, as no suitable slipway or dock was available. The solution lay in the use of a jack-up platform, very similar to the ones built earlier by IHC Holland for other civil engineering works. The platform stood in the water close to the yard. At each stage of the assembly, a prefabricated module was positioned under the platform and attached to the pontoon. Then the pontoon and the module were jacked up. The hull with its columns was towed between the legs of the platform and the module lowered into position. A unique method of assembly and proof of the builder's ingenuity. Then one day early in 1975, Viking Piper was towed from the IHC yard in Rotterdam to Lerwick Harbour in the Shetland Islands to undergo her final trials. Soon, the preparation work over, Viking Piper was ready to start her first commission under contract to British Petroleum. Her job, to lay 36-inch diameter pipe from Grotwick to the Ninian oil fields, a distance of 102 miles through the notoriously hostile northern North Seas. When laying pipe, the barge holds her position and makes forward movements by means of anchors, attached by about 2 miles of 3-inch steel cable to winches situated in the pontoons, 7 along each side. An exact route for the pipeline has been surveyed along the seabed. The barge has to follow this in all weather conditions. The winches and their 14 anchors are controlled from the tower by a computer system. At most, 2 men are needed to move the barge. As the barge advances, the tugs leapfrog some of the anchors ahead, so a repositioning hold-up should never occur. Piper is designed to hold and maneuver with as few as 8 out of her 14 anchors.
Viking Piper, stand below us. Be able to take us straight alongside, please.
Very well. Go ahead, anchor up then.
On the port side, straight away. Okay, see you then.
The pipeline is laid from the center line of the barge, enabling supply ships to offload on both sides of the barge simultaneously. If bad weather prevents offloading, The barge can continue to lay, having a storage capacity of over 7,000 tons, equivalent to about 3 days of average laying. The pipe comes aboard in 40-foot lengths and is welded in 2 stages. 2 40-foot lengths are welded into a single 80-foot length at the 3 stations of the double joint line which runs along the port side. It's then moved across to the center firing line, the beginning of the pipeline itself. Each time the barge now moves forward by 80 feet, the new join progresses down the firing line, halting at 3 welding stations and continuing through the tensioners, through an X-ray bay, and over the stern ramp into the sea. The 40-foot lengths are rolled into the first welding station and lined up end to end by compressed air powered rollers. An internal clamp accomplishes the final critical alignment and proper spacing, allowing for a clearance of 0.065 of an inch between pipe ends.
Just a hair, 30 seconds. All the way around. Hang on now. Mile and a quarter, touch it down just a touch. What do you say? All right. Ready? Yeah. Go.
The welding is done automatically by machines equipped with 4 welding heads. Each head describes a 90-degree arc around the join, whilst the welding machine is locked in position on the pipe. The system is quick and maintains the required high quality of weld. As soon as the welders complete the first weld, the root pass, the pipe travels to the second double joint station for additional filler passes.
Back her up. Just a touch. Back. That'll do it. Okay, we're ready.
The completed weld is checked by X-ray.
Close it up on top.
Once again, the pipe is lined up for welding, but this time it's to be connected to the main pipeline that runs through the barge, down to the seabed, and then along its charted course all the way to the distant shore. In the control tower, the anchor operators watch the progress along the firing line on closed-circuit televisions. They await the signals from the various stations along its length that give them the all-clear to move the barge. Two men with the winch controls at their fingertips now move the 50,000-ton barge ahead by precisely the length of a double joint of freshly welded pipe. That is, 80 feet. As the barge advances, the pipe slides gently down the stern ramp, and with the anchors carefully controlling the move ahead, the pipe is laid down into its surveyed position on the seabed. As the barge is frequently moving, the anchors must be repositioned by tugboats to maintain a balanced anchor pattern. The winch pays out cable as the tug heads for the new anchor location. The control tower operator knows precisely where this is and guides the tug skipper to the spot. A computer displays the new anchor pattern. A switchover from manual to the computerized winch system. Now, one man moves the barge by 2 joysticks, which control all winches available for operation. The barge is equipped with 3 navigation systems, including a satellite fix for determining her exact position. After each move, a computer selects the most accurate of the 3, and from this calculates the theoretical touchdown point of the pipe, which is then plotted on a chart. Come October 1975, Viking Piper found herself in the midst of a force 8 gale, with gusts of 60 mph. The tug skippers had to fight to pick up the anchor buoys. But on the barge, it was business as usual, the business of laying pipe. Here was the proof the designers had been so confident of. No other barge had remained on station in the North Sea through October. Yet Viking Piper, steady as a rock in a force 8, was still laying. The men who built and crewed the Piper had good reason to be satisfied with their first season, in spite of early teething troubles which cost valuable time. After a winter refit, the Piper resumed its work on the Ninian line in April '76. It recovered the line and laid the remaining 60 miles in 50 days, uninterrupted by winds of 50 knots and waves 35 feet high. A success which is a tribute to the capabilities of speed and endurance of the 3rd generation lay barge, the Viking Piper.